Welcome back, everybody. Today, we're going to be taking a deep dive into Physics of Language Models, Part 2.1, Grade School Math and the Hidden Reasoning Process.
Interesting title.
It is. I was really drawn to this one. And it's by Tian, Zicheng, Yuanzhi, and Zeyuan Allen-Zhu. And, it's not just about, pushing those benchmarks and getting the highest accuracy.
Yeah, seems like it's going a bit deeper than that.
Yeah, it really is. We're going beyond just, did the model get it right? Like, how did it get there? And why? What's the process that it's going through? What stood out to you when you first looked at this?
One of the first things I noticed is that the researchers decided to create their own synthetic data set.
Yeah, I was going to ask about that. I mean, why not use something like GSM-AK? Isn't that kind of the standard for, evaluating math reasoning with language models?
Well, yeah, it is, but the authors of this paper bring up an interesting point about data contamination. They're concerned that data sets that already exist, even GSM-AK, may have seeped into the training data of some of these large language models.
Oh, so it's almost like it's cheating, right? Like the model's already seen these problems.
Exactly. Like, think about how these models are trained. They're trained on massive amounts of text data, and that includes text from all over the internet. It's highly likely that some of that data includes, solutions to math problems from these benchmark data sets.
So it might not be actually reasoning. It might just be recognizing a pattern.
Precisely. And that's why they decided to go with a brand new data set called IGSM, which stands for Infinite GSM.
Okay, so IGSM it is. Tell me more about that, like how it works.
So they basically built this hierarchical structure to mimic the way we organize information in the real world.
Okay.
You have categories like school, classroom, and backpack, and each of those categories contains different items.
So different types of schools, different classrooms, different backpack.
Exactly. And by doing this, the model has to actually learn English concepts.
Okay.
For example, it has to learn that classroom can refer to a dance studio or a film studio, depending on the context. So it's not just about numbers anymore. It's about understanding language and relationships.
That's really clever. It adds this whole other level of complexity to the reasoning.
Right.
So how does that translate to the actual math problems, though?
Though they use something called a dependency graph.
The dependency graph. Okay, hold on. Let's break that down. What is that?
Basically, they're using the dependency graph to outline the arithmetic relationships between all these parameters.
Okay.
So for example, let's say you have a word problem. There are 5 schools, each with 10 classrooms. Each classroom has 20 chairs. How many chairs are there in total? The dependency graph is going to map out how those quantities are related. Like the number of schools influences the number of classrooms, which then influences the total number of chairs.
Oh, so it's like a visual representation of the problem's logic.
Exactly.
Okay.
They don't just stop there. They actually generate chain of thought, or KOT, solutions for each problem.
Cortia familiar. It's like laying out step by step how a human would think through it.
Precisely. Okay, so you have the problem itself, you have the dependency graph showing how everything's related, and then you have that KT solution demonstrating the logical steps.
All right, so that's IGSM, categories, items, dependency graph, KOT solutions. Sounds pretty thorough. What kind of language model did they use for this?
They used a GPT-2 model with rotary embedding, trained on this IGSM dataset.
Okay, GPT-2, good choice. What were they looking for in terms of evaluating how well the model performed?
So, of course, they were looking at accuracy, is it getting the answers right? But they were also really interested in how often the model would generate the most efficient solution.
The most efficient.
Meaning the shortest possible chain of reasoning to get to that answer.
Right, because if it's efficient, it probably understands the problem well enough to, go the quickest route.
Exactly. That's a good indicator of understanding.
Yeah, okay. So what were the results? How did it do?
So the model achieved a pretty high level of accuracy on the IGSM problems. In some cases, it actually outperformed human few-shot learners.
Wow. So not just keeping up with humans, but exceeding them in some cases.
Exactly. Now, of course, the question is, was it really reasoning or was it just relying on, memorized patterns? And that's where the out-of-distribution or OOD problems come in.
OOD, okay.
These are problems with much longer reasoning chains than what the model saw during its training.
Okay.
And what's really interesting is that the model performed really well on those OOD problems, too.
So it was able to generalize its knowledge and apply it to new situations?
Exactly.
Okay, that's impressive. That's really cool. That means it's not just mimicking, it's actually learning and developing its own, processes.
That's right. And this is where the researchers got really clever. They designed a set of probing tasks to kind of peek inside the mind of the model and see what's going on with its reasoning.
Probing tasks. All right, let's dive into that. What are they looking for and what do they find?
Picking up where we left off, let's talk about some really fascinating results they found about model depth and how that impacts reasoning.
Yeah, you mentioned before how this study kind of challenges the idea that, Bigger is always better when it comes to language models. Like, just keep adding more parameters, and it's going to get smarter.
Right, there's this kind of assumption in the field that model size, just the number of parameters, is the key to better performance, especially on these like complex reasoning tasks.
More parameters, more capacity to learn.
Yeah, exactly. But what's really interesting is that this study is showing that depth, like the number of layers in the model, might be even more important than just the overall size.
So are you saying that, like, a deeper model, even if it has fewer parameters overall, could actually reason better than a shallower model that's bigger?
That seems to be what they found. Yeah, they actually ran experiments comparing models with, different depths, different sizes, all trained on that IGSM data set we talked about. And what they saw consistently was that deeper models were doing better, getting higher accuracy, showing better reasoning compared to these shallower models, even when those shallower models had way more parameters overall.
That's pretty convincing evidence for the importance of depth. But, like, why? Why does depth seem to matter so much for reasoning?
So they dug into that, and they found this really interesting correlation between the depth of the model and its ability to identify the parameters that are actually needed to solve the problem.
Okay.
What they noticed was that deeper models were much better at being able to pick out those necessary parameters, even when they were kind of further away in that dependency graph.
So the deeper models are kind of better at seeing those connections, even if they're more complex or maybe less obvious?
Exactly. Deeper models just seem to do a better job at navigating that whole intricate dependency graph, like tracing those connections between parameters across, longer chains of reasoning. It's like each layer of the model is adding another level of depth to its understanding, letting it grasp these more intricate reasoning patterns.
That's cool. So it's not just about how much a model can remember or store. It's about how well it can connect the dots, right? And depth seems to be key to that.
Absolutely. It kind of changes how we think about designing and training these models for these harder reasoning tasks. Just focusing on making models bigger might not be the best way to go. We need to really pay attention to that architecture, that depth, to get the most out of them.
This is really interesting stuff. So we've seen how these language models can do some pretty amazing reasoning, even better than people sometimes, and how that depth is crucial for that ability. We've also learned about the mistakes they make and what might be causing them.
Yeah, it's really given us a better understanding of the physics of these language models, how their internal mechanisms actually work.
I'm curious, what were your biggest takeaways from this study? What really surprised you or stood out to you?
I think what struck me the most was the model's ability to go beyond just mimicking how humans would respond and actually develop its own internal logic and reasoning processes. That level 2 reasoning we talked about, where it uses more information than it needs to just solve the problem, that was really fascinating.
Yeah, it's like it's not just trying to get the right answer. It wants to understand the whole picture.
Right. And that opens up some really cool possibilities. Imagine language models that can not only solve problems, but can explain their reasoning in a way that humans can understand. Or models that can figure out what they don't know and then actively go out and find that information.
That would be huge. They wouldn't just be tools. They'd be collaborators, helping us with scientific discoveries, problem solving, even creative stuff.
Yeah, exactly. And then the stuff about model depth, that just adds to it. If deeper models really are better at reasoning, then maybe we can unlock even more of their cognitive potential by designing them in a way that encourages that deeper, more hierarchical processing.
It's not just about size. It's about building smarter models that think in a more strategic way. That's really exciting.
It is, but with any powerful technology, we have to be mindful of the potential risks too.
For sure. We talked about those errors models make and how important it is to figure out what's causing them. But then there's the bigger picture, the societal implications of this.
Absolutely. As these models become more and more advanced and part of our lives, we have to be really thoughtful about how we design them, train them, and use them. They need to reflect our values, be used responsibly, and ultimately benefit everyone.
Yeah, it's a lot to think about, but we can't ignore it. What's happening now is shaping the future of AI.
Right, and it's up to all of us to make sure that future is a good one. This study has given us this incredible glimpse into what language models can do, but it's also a reminder that we need to approach this technology with both excitement and caution.
Couldn't agree more. Okay, so we've talked about what this model can do well, where it falls short. But there's one more piece to this puzzle. What does all this mean for the future? How might this research shape the future of language models and how they impact all sorts of fields? That's what we're going to get into in our final segment. All right, so we've really dug into the nuts and bolts of how this language model tackles these math problems. But now I want to kind of zoom out a bit. What does it all mean? Like, what are the implications of this research for the future of language models? How might this impact, well, Everything.
Yeah, that's the big question, isn't it? And it's something that a lot of researchers are thinking about right now. This study, even though it focused on this specific type of reasoning, I think it gives us some really interesting clues about the broader potential of these models and where things might be headed.
Okay, so let's speculate a little. What are some of those clues? What possibilities are you most excited about?
Well, that whole thing about level 2 reasoning, that's really fascinating to me. Where the model wasn't just satisfied with finding the answer, it actually wanted to understand the deeper relationships between those parameters.
Yeah, it was going beyond just getting it right. It was building a richer understanding of the situation.
Exactly. And that kind of opens up a whole world of possibilities. Like, imagine language models that can not only solve problems, but they can explain how they got there in a way that humans can understand. Or models that can actually recognize what they don't know and then go out and find that information on their own.
That would be amazing. They wouldn't just be tools anymore. They'd be like collaborators, working with us on scientific discoveries, problem solving, even creative work.
Yeah, exactly. And then you add in the findings about model depth, and it gets even more exciting. If deeper models really are better at this kind of reasoning, then maybe we can push that even further. By focusing on designing architectures that allow for that deeper, more hierarchical processing, we might be able to unlock even higher levels of cognitive ability.
So it's not just about making models bigger, it's about making them smarter, designing them to think more deeply, more strategically.
Exactly. And that's incredibly exciting. But of course, we have to be realistic too. Like with any really powerful technology, there are potential downsides and challenges that we need to think about carefully.
Right. We talked about the others that models make and how important it is to figure out why those are laughing. But there's also the bigger picture, the impact this could have on society as a whole.
Absolutely. As these models become more sophisticated and more integrated into our lives, we need to be very careful about how we design, train, and use them. They need to be aligned with our values, used responsibly, and ultimately benefit all of us.
Yeah, it's a big responsibility, but one we can't ignore. The decisions we make now are shaping the future of AI.
Right, and it's up to all of us to make sure that future is a positive one. This study has shown us just a glimpse of the amazing things language models can do. But it also reminds us that we need to approach this technology with a mix of excitement and caution.
Well said. I think this has been an incredibly insightful deep dive, and honestly, I feel like I've learned a lot today.
Me too. It's been a fascinating conversation, and I think this paper is going to continue to inspire new research and new discoveries for a long time to come.
And to our listener, thanks for joining us on this journey. We've only scratched the surface of this whole world of language models and AI, but hopefully we've sparked your curiosity and left you wanting to explore more. Keep learning, keep asking questions, and keep pushing the boundaries of what's possible.